keen interest on AML techniques and all the technologies, how they are evolving and all. Uh, I will discuss some of the different phase shifting techniques for dual active bridge converter in electric vehicle expression application. Not only electric vehicle application, you can go for any other application. But I have a small work on electric vehicle application, so I am going with that. Uh, I think everything is fine,
Sorry,
participants. I think around
sorry,
98 participants are there.
sorry. Can I interrupt? Sorry. One question. So, do you have a separate time for asking the question, or shall we interrupt during the presentation? How is it?
You can,
Yes,
sir, we can
after
go with
the
the.
yeah,
Uh,
yes, sir. After the session, when you will complete, then you please note down the questions. Okay.
Okay.
After the session, you can ask him.
Okay. Okay. Thank you.
Currently, Hemanth is
After
in
the session,
internship. Okay. Currently, Hemanth is in internship in LG. Okay. So he is outside of our campus. Okay. So first let him complete. After that, you please noting down and you will ask. Okay. So he has done a lot of work in this domain regarding the phase shifting and all those things for a DAV converters. So that is normally using for different integration purpose of the storage. Okay. So he will discuss on that. Okay. Some simulation results also with him. So let him complete, then you will ask. Definitely he will help you. Okay. Thank you. Please
Thank you.
carry on, Hemant.
yes, sir, yes, sir. Welcome to the AML based control designs and their applications in real time platform. Actually, this course AMCDARP we call it as 2024. Actually, this kind of we are normally studying about the different patient techniques or different torque control or different motor drive mechanisms and all, and we are now in a position to integrate those to AML because the entire thing is grabbing by AI so that they can our control techniques and our efficient power transfer mechanisms are very now easy. And let's go to our second slide. This is the my title of the presentation, that analysis of different phase shifting techniques and for DAB converter. DAB means already most of you know dual active bridge converter. Why I choose is there is a more efficiency in compared to our different conventional converter topology. This is what I did work for EV application, and I will discuss small things based on AML based controllers also for basic understanding. Let us go. This is my outline of the slides of today's discussion. This is the first outline. Let us read about that introduction to DAB converter. Means in that we will enclose with how dual active bridge converter work and what is the topology and what kind of results, simulation results we got from the observations, and what are the different phase shifting techniques in dual active bridge converter. I think I am audible, right, participants?
Yes, audible.
Yes, sir, audible, audible.
Yes, sir.
Okay, thank you. These are the there are different phase shifting techniques. Why we are going for phase shifting techniques also I will discuss in detail, and here this domain we are my work is based on comes under power electronics domain. So power electronics, in how that we are integrated that AML in power electronics. I will discuss that AML part in basic part only. In coming sessions you will learn more about that practical implementation of the AML, and there is real-time implementation of the AML controllers. We will discuss a few things and what are the applications and all. We will go for conclusion and future directions also. Actually, this is the DAP converter. I'm showing you some of the pictures. What are the applications my converter suitable for in EV related? The chargers are actually dual active bridge converter is a bidirectional converter. All of you know, and how this type of converter increases, using of the converter increases because of the numerous advantages here. that what are the advantages we will discuss in the coming slides. But there is the main thing is bidirectional power transfer takes place. If there is a bidirectional power transfer takes place, then automatically our battery and our supercapacitor and our integration of energy takes place very well. That there are separate algorithms for the design of the battery controller supercapacitor integration with our load, whatever the wheel we run, that whatever the motor we drive, that these are kinds of things are there. And let us why I took DAP converter. I will give small introduction. Actually, electric vehicle. Why electric vehicles? First thing, why electric vehicles we are going with? Because the power conversion technologies, power conversion technologies are needed for that getting the electric vehicles to run. Before that, electric vehicles are growing technology because of the greenhouse gases emissions for reduction, and we are depending on the fossil fuels for better reliability on the future development, future our future living. And that thing is our satisfaction, our livelihood satisfaction only. When it comes to our power electronic converter components of EV systems, they play a key role in flow of energy between the motor, battery, and other systems like supercapacitor and auxiliary components like lighting. In then comes to car, and there are huge number of EVs also. There is a growth, but there is a still clarification about that battery, that charging of the battery, how much the charging stations or more are needed, and how that charging station and our load with withstand with what if we install more number of charging stations, how that load withstand with the power system capability, and all. We still there is a some kind of challenge is there, but the impact of the EVs are very good in already in European countries all are existing. How they are planning, how they are went by decreasing that some kind of petrol diesel kind of engines. So we are going also move forward in that area only for decrease in the greenhouse gases effect and all those things. And there is a kind of thing whatever we have to see in. I am coming to particularly converter now. What is in DAP converter? What are the parameters we have to see for in kind of design or whatever the power management capabilities for better efficient power transmission, and we will see now. And actually, efficiency is the major part of the power conversion, and that vehicle means that whatever the converter we make that affect the performance characteristics and the vehicle range, the drive range and of the vehicle, the power consumption of the vehicle also very important. Because if we make a vehicle, if we make a install a power converter in that, how much time it will run, we have to predict that vehicle, and before that we have to get the charging station, so that our converter should give the information, means whatever the power transfer takes place, that kind of power, how much that drive can sustain with the per kilometer, how many kilometers it can run per, that kind of thing is very important also. And when comes to that other things like this is dual active bridge converter, how it would be. There is two bridges. Initially it is a DC-DC converter only. Based on the input of the DC, we are getting a primary bridge, one kind of inverted output, that is AC output. Again we are making up, means by using that high frequency transformer. Here using high frequency transformer because our compact design, because of the our compact design is very important in making the converter, in the selection of the components and all. They should be very keen, because we are making converter is not a small thing. We have to see the whether their protection is good, or whether their components are okay with the selection, or whether we are going for high costs are, because the cost management also very important. We are still as a in a developing country. We should see with the less cost how much reliability of living is there for us. That kind of thing we have to think, so that we have to see the cost, reliability, cost, and compact design and efficient power transfer of the converter is also very important. This is the type of thing we drive the load, and this is the operation of the dual active bridge converter. This is a primary mode of operation when the switches are on. Here, this is a primary mode of operation. There is a cycle from 0 to pi. There is a switches Q1 and Q4 on. If the Q1 and Q4 on, there is a positive voltage appears around the primary winding. Around the primary winding, you appear the positive voltage. There is a second half cycle, means this is the primary inverter operation. When it comes to secondary inverter operation, that whatever the voltage generated in the first cycle, that by using that high frequency transformer, that uplifts means that voltage, AC voltage only increases, that voltage again transfers to the secondary winding. Meanwhile the power transfer takes place like this modes, and this type of modes talk takes place. And this actually here phase shift is the main important thing in the secondary inverter operation. This phase shift makes our converter to operate by reducing the switching losses. But if our switching losses are reduced, then voltage stress on the switches reduce. If the voltage stress on the switches reduce, then our reliability of the switches is more. If our reliability of the switches is more, then our reliability of the entire device, our maintenance costs is decreases. Maintenance cost decreases means our our converter will get more time. Reliability of the converter is more. If the reliability of the converter is more, then our vehicle runs with good factors. Means if like this, not only converter, there are motor, there is a motor, there is a battery, there is supercapacitor. If all those considerations so very good, then our vehicle will give better performance, so that our product will be very good, and that in market also it gives a good understanding for the people that this kind of product is. That type of design we have to consider. What are the design parameters also I will discuss in this. And this is the second mode of operation. This is a reverse mode of operation. This is first is forward mode. Forward mode means whatever the power is transformed from the low voltage side to high voltage side. And this is secondary. This type of, what is this? This is high voltage side to low voltage side. There is actually this is a bidirectional converter, right? So bidirectional power transfer should takes place. And there are some of the things when there are some of the advantages why we are why we are selecting DAP converters. What are the advantages in EV application? That is, first thing, primary thing is bidirectional power flow. Bidirectional power flow means the handle of the DAP converter can handle the power in both the directions, which is better for applications like battery charging or battery discharging, and regenerative braking case also. Regenerative braking case also very important. It is not like the energy wastage of the energy takes place. That wastage of the energy while running, we are utilizing for the charging of the battery. This is also one of the good thing. And this DAP converter is high efficiency because of using of the soft switching methods. This soft switching is very much important because that soft switching methods means ZCS techniques. ZVS means zero voltage switching. ZCS means zero current switching. This kind of things means ZVS, ZCS will come when it will come This based on the resonant characteristics, resonant kind of action of the switches. This ZVS and ZGS, what happen, it will reduce the losses on the switches, so that our efficiency would be very high because of this swap switching methods. And our what is the galvanic isolation? Or there is a term galvanic isolation. What is this galvanic isolation? The high frequency transformer within tap converters provide. I think we are here only. Okay. Next overview of the EV power conversion requirements I will tell. Before that, we will discuss small thing about galvanic isolation. Galvanic isolation means there is a high frequency transformer, right? The high frequency transformer provides some isolation between low voltage side and high voltage side. That type of isolation is galvanic isolation for safety and reliability. That type of galvanic isolation is very much good for dual active bridge converter compared to conventional converters. And the final thing is flexibility and scalability of the converters. Generally, dual active bridge converters are easily adaptable to different load variations, because as we ride a vehicle, when we ride a vehicle, we are not in a constant speed ride. We are changing the accelerator as we ride a car. We changing which automatically, some kind of cars has automatic gear system, so that automatically gear changes due to the speed changes. This type of variations also that converter has to manage, that how that kind of intelligently that converter senses all these parameters. Then we how good our management of the converter takes place. That's the flexibility and scalability case. And these are the power conversion requirements, the EV power conversion, how it takes place. This from battery to motor, there is a DC to AC type of conversion. Actually, there are some of the key parameters for the evaluation in EV. We will discuss later that. And this is the DC to AC conversion type of thing. Battery to motor means automatically the motor is almost induction type of motor generally used in railways. When it comes to our electric vehicles, that PMSM type of motor we use because of the different type of advantages that has, because that some of the cases the torque is manageable with the PMSM motor almost. Actually, performance that guy DC motor guy, but that brushes and all the commutational losses are there, so that we will go for the generally go for the induction motors or synchronous motors which operate like a DC motor performance, so that our by using that vector type of thing, vector thing, there are some kind of things actually I'm not getting that. Okay, the vector control of thing, we are adapting the DC motor performance characteristics like that. This motor is AC power, AC motors we use. This DC to AC conversion for motor operation, this requires requiring high power. Actually, this dual active bridge converter, man can manage this EV, can make the EV this high power density and efficiency. And bidirectional power transfer already we discussed. We don't need to much think about the battery and auxiliary systems. Auxiliary systems means suppose some lighting, a case of thing. Lighting, heating, and infotainment means our generally we use some kind of music things. So many kinds, so many members are interested in this that kind of thing. And when it comes to our slide is not changing, I think. And already we discussed about this advantages of dual active bridge converter, this high efficiencies of switching and flexible and compact size. These are already we discussed things. And what are the key parameters, key performance parameters in EV applications generally? These are the main things. Suppose our vehicle, suppose electric vehicle came outside with some specific norms and specific testings. What are the testing procedures involved in this? Suppose if we are making an auto and we are releasing into a market product, that product we are releasing into the market. Before entering into the market, what are the testings? What are the testings? Generally, there is an insulation resistance test of the vehicle. Actually, IR test. You most of the people may not may hear, some people may hear, but what is that insulation resistance test? If there is any leakage of the electricity of the vehicle, for the vehicle, that kind of electricity leakages are not advisable and not good for if they release in the market. So that they will test each and every cable. There are different type of cables. What are the type of cable? What the table cables indicates generally in real time industry applications I am discussing. Actually, in research purpose, we will do different things, but real time industry purpose, the cables. What are the cables generally? There is a related to sensor related cable. They're related to, there is a in total vehicle. Suppose if we take an auto or if we take a car, there is a motor. For a motor, in case of motor, whether there is an electricity is passing, electrical leakages, electrical flux leakage, magnetic means there is a magnetic field and electric field. If they both interact, then they automatically, if any one interacts, if there is a flux, there is a, definitely there is a current, there is a leakage of the electricity. So that kind of thing. In battery there is one cable, that in motors there is another cable, on motor side there is another cable, and there is a in sensing action. Meanwhile, in sensing also, if there is any type of leakage currents flow, that case is different. Like that, we will test each and 5 to 6 cables majorly, so that we confirm that there is no there is more resistance for this, insulation resistance is more, so that okay, then we can release this product into market. Before that, there is a motor control unit, vehicle control unit. Generally in EV, what is the motor control unit? Vehicle control unit. These motor control unit and vehicle control unit, these are all are integrable actually. These kind of things generally, what are the things comes under motor control unit? This actually there is a huge things there we have to learn. Generally, there is a charger. There is a charger, what charger, DC to AC conversion, AC to DC, sorry, AC to DC conversion. Here, 230 volts charger. Generally, in charging station, if we take 230 volts charger, that converts our AC supply to DC. Because why we are converting our DC supply? Because our entire electric vehicle that operates on the DC bus system. That DC conversion takes place to charge the battery. We are charging battery. So that DC. In suppose, according to my knowledge, when my industry experience of that battery around 42 volts battery, it is charge. Based on that, there is that battery is integrated with the motor control unit and this PMSM motor. PMSM motor, why generally we use PMSM motor? For better torque output. That PMSM without brushes, that DC type of thing is already we discussed about DC performance and all those things. That DC performance is appears, so we generally go with this PMSM motor. That PMSM motor battery is integrated with motor control unit, and that motor control unit also has to do one thing. What is that? It has to sense the voltage and current. Voltage and current means speed and torque. That's we know the, according to our basics understanding, the voltage and current means speed and torque. That speed and torque, whatever the parameters are there, these parameters senses by the motor control unit as a feedback, that in terms of voltage and current. In terms of voltage and current, this motor control unit, okay, manages the drive range of the vehicle, and this motor control unit is also embedded with vehicle control unit. This vehicle control unit, what it generally manages this motor control unit and gearbox. There is a actually in automatic gearbox is there, or whether we go for manual gears. And generally, electric vehicles, auto system gear only. There is a major thing, and this gear automatically changes based on the vehicle control unit, this motor control unit performance. This charger and battery and motor control unit, these all are connected with vehicle control unit. And what are the other things which are connected with? I am discussing just basic EV, because if we have some idea about EV, so that you can understand the how we are making the converter, what are the design parameters we are considering for the converter design. That's why I am discussing about some you are getting some practical experience, practical with my lecture. I am giving some you feed inputs from the practical type of thing, better than theoretical type of thing. Hello. Hello, am I audible?
You are audible.
Yes, sir. Yes, sir. Okay, sir. And this battery and this whatever, generally lithium ion type of battery we use because of the best performance in our characteristics of the speed torque characteristics for, not only indirectly it gives speed torque characteristic, but the charging and discharging and lithium ferrophosphate, generally this kind of battery we use in this type of electric vehicles. And this battery is also connected with our auxiliary batteries. Auxiliary batteries means this it is of generally 12 volts generally. This
Please raise the
comes,
volume little more.
sir.
Please raise the volume little more. It's not clearly audible.
Okay, sir. Okay, sir. Now, okay, sir. Now, am I audible with better volume?
Yeah. Now it is a little better.
Yes, sir. Yes, sir. Yes, actually, this 12 volts, whatever battery, auxiliary battery, what we say, this also use it for the starting and lights in the, if we see in the vehicle, there is a lights, and there is a, I said already, I discussed about infotainment and music and all these kind of things are there. And this all the time kind of things, already I discussed about the cables and all that, battery cable, battery also there is a two terminals. So we will test in the two terminals also that, whether that comes under incident, there is an electrical leakage or not. And this auxiliary battery, this pivot and all those, this is the generally electric vehicle. This, for this we are making the key performance metrics, whatever we can consider. Actually, efficiency all over we know that ratio of the output power to the input power, reflecting that means output automatically. This like a efficiency like a gate. Am I audible, sir? Hello.
Yes, you are audible.
Okay, sir. And this maximizing the efficiency.
Yes, you are audible.
Yes, sir. This actually this maximum efficiency is the better for the minimum energy consumption. Minimum energy consumption means we are almost in the right path, that reliable thing. And this kind of metrics, whatever this power density means power output per unit volume. This is this indicates the some kind of way that. Compact size of design means that weight and our parts what we won't go for better, higher parts than the required values. And there is a voltage regulation, this is one of the factor, because we have to always go with this desirable output voltage. And there is a thermal management. This thermal management also very important, because there is a, if we our converter or any battery, if they any kind of thing, it dissipates heat, it damages whole vehicle. So all the type of thermal related tests also, they are very keen in making, in giving the permissions and all. This effective thermal management also gives our long time management of the reliability of the vehicle increases. And this efficiency considerations already we discussed about the soft switching and the transformer design. And I didn't discuss about gate drive optimization. Gate drive means I am coming to the phase shifting techniques. This phase shifting comes under this gate drive operation, because whatever the pulse we are giving, whatever the gate pulse we are giving, based on that our converter operates. This pulses generation is very much important. This affects the duty ratio of the our converter. If this duty ratio is very much important for the getting the desirable output voltage or output power what we require. And this is the efficiency is the one of the main concern on dual active bridge converter design. And this also this efficiency also already discussed about minimizes the losses around the switches, not only in the switches, in the high frequency transformer also. That transformation part is very good, so that our control circuit control of the circuit also very good. And what are the kinds what are the things that comes under voltage regulation or this duty cycle adjustment, thus efficiency optimization and closed loop control and voltage sensing. This voltage sensing, actually I said about this motor control unit. This motor control unit generally senses the parameters. Based on that, there is a duty cycle improvement. This duty cycle improvement makes our better output voltage, better thing. And this thermal management challenges in the EV environment already we discussed. This thermal management is also very important critical aspect in wherever the heat is dissipation takes place. There is some of the switching losses and the current and more current flow. With the more current, there is damage to the entire device. This thermal protection is very important as we discussed now. And now comes to the phase shifting techniques. Dual active bridge converter. What are the phase shifting techniques? And why we are considering this? Actually phase shifting involves the altering of the phase shift between the low voltage bridge and high voltage bridge. And which this type of I am pronouncing low voltage and high voltage better to you may hear about primary and secondary bridges. This type of converter, this mouse is not okay. This type of this is the primary bridge and this is the secondary bridge. And this, what are the important things? This phase shift has a major impact on the power transfer efficiency of the converter. By slight variation of the phase shift, there is a significant gain in the performance of the converter takes place. This gain what affects this may cause into better efficiency. Better efficiency also more times we are discussing here. I think you may be bored. Better control of the power flow and reduction of the stress of the components. These type of things generally it will take. This is the block diagram of the phase shifting techniques of the dual active bridge converter with a photovoltaic source for electric vehicle. As a type of simulation kind of thing, I involved this my DC as PV source, whatever the voltage, whatever the output coming from the PV, I took as a DC input, and I went for the PI control for basic simulation, and based on that this converter I set it for electric vehicle. And this block diagram is application of phase shifting techniques in a dual active bridge converter with a photovoltaic source for an electric vehicle. Shows it shows generally several components involved in this like PV source, primary and secondary inverters, and output filter. Output filter means that capacitor filter, and this phase shift controller also there. This phase shift control means whatever the techniques I have discussed. I have made here. This phase shifting is SPS, DPS, TPS, and NPS, and this electric vehicle. When it comes to operation, actually, the PV source supplies this converter I am explaining operation. When it comes to the operation, that PV source supplies a DC power to the primary side of the full bridge inverter, which converts into AC, which is a high frequency. Already we discussed, but I am leaving with that thing. And this edges thing, duty cycle and all this thing. By incorporating this type of phase shifting techniques, there is a manageable managing of the bidirectional power flow. This is the one of the important point. And this scenario is very much helpful for the EV application and all the controlling of the driving and regenerative braking and all those things. And these components, various phase shifting methods used in our DAB converter are single phase shift, dual phase shift, this one, single phase shift, dual phase shift, triple phase shift, and multi phase shift. And already I discussed about this phase shifting techniques in dual active bridge converter. And this is the very much important slide. Design considerations for the phase shift control. Design, what are the design considerations we have to choose? What are the design considerations generally we have to choose? The switching devices. What are the switching devices? Generally we go for IGBTs or MOSFETs. Why generally we go for MOSFETs or IGBTs based on our application. Based on our application, we choose suitable devices. Am I audible, sir? No? Hello, sir?
Please speak little loudly. Sometimes you are okay, sometimes your volume is coming down very
Okay,
low.
sorry for that, sir. I will. And these switches are very important, actually. The generally in choosing the switches, there is a different kind of data sheets available. These data sheets will guide us how much voltage is available, how up to how much voltage we have to consider for the selection of the switch, because that selection of the switch is also very important. If we select more rating, then our next experiment means our next research or next type of exposure what we get, we have to utilize the resources so that we are have to get the appropriate selection of the component. And this comes under transformer design. The transformer design means the number of turns in the transformer, and if it is high frequency, generally we go for high frequency only because there is a more compact set of design we can expect. And this is the control system. Control system means accurate timing of the switching. This phase shifting techniques also comes under control system. Accurate timing of the switching is important for the power flow regulation and filtering components. There is some kind of harmonics involved in this. This harmonics makes our generally they eat our brain because we have to reduce that component harmonics, because if that reduction of the harmonics only, then only we can satisfy with the better output. If we satisfy means our converter will comes under good design. And there is some of the protection mechanisms are also very important. What are the protection mechanisms which are essential to safeguard the converter from overcurrents, over voltages, and other faults? This protection, generally we go for snubber circuit and all those things, because that whatever the voltage appears, that capacitor has to take, and based on that our converter comes under, our switching losses will comes under reduction. And majorly we go for application, for application to application it is different. And you may heard about series resonant inverter. This inverter also very much good usage in present industry purpose also. This inverter actually generate a smooth high frequency AC, and with the advantage is almost there is a reduction in the components with high frequencies, and there is a good high voltage also, because our almost all the applications which are our usage are high voltage, high voltage applications, because we have to at high voltage we have to use that. We have to, suppose it comes out of electric vehicle, there you have to drive that vehicle. We have, if there is a load variations, automatically there is a current improval takes place. Ultimately there is some kind of voltage also involved in this high frequency series resonant inverter also came under good thing. Actually there is a resonance, some kind of resonance is also very important. Actually I discussed about the ZBS and ZGS, but I will discuss some kind of good detailed thing of the ZBS and ZBS and ZCS, because this kind of resonance is very much important for decreasing our oscillations. This type of suppose in kind of this type of sir.
Carry on, Hemanth, carry on.
Okay, sir. Okay, sir. Actually, this frequency response, suppose for any inverter, what we see, I am going with somewhat bit 2 minutes out of the concept, because that inverter design also very important. So I will come back with that inverter, what the gain of the inverter and frequency response. That frequency response is very much important, that for the appropriate design of the resonant circuit. This resonant circuit comes under LC series resonant, most of you know. This series resonant inverter also, there are different kinds of connections for getting obtain the frequency response. Generally that is series connection, parallel connection, series parallel connection, and generally this series parallel connection is the most updated one. And this peak resonant, the peak is that quality factor and frequency. These are the very much important things. If our peak is more, then the quality factor is also more, then our our operation circuit goes under good operation, good thing, because most of the loads are inductive loads only, above the resonant frequency only we operate. And there is a thing which load, and there is a most important thing we have to know, as we already know that as the load increases, frequency decreases. This kind of variations whenever load changes, even in case of the any kind of application, you will encounter this type of thing. When there is a load increase, frequency decreases, and when there is a load decrease, frequency increases. But what is the way for improving this kind of situation? What is the situation we are taking into consideration? This load, whenever there is a load increases, automatically there is a frequency decrease. Then who will compensate that frequency? That for operating at the resonance frequency, at resonance frequency is the main consideration, because our maximum current flow takes place. If our maximum current flow takes place with the load, if that maximum current flow takes place, then our resonant peak is more, and within a less kind of supply what we give as a DC, we will get a good output of AC for better high voltage applications. This kind of nature is possible with the resonance. Whenever our frequency load increases or frequency decreases, it is below resonant frequency it is coming. If we increase that resonant frequency, then our load characteristics are very good. Based on that, our operation is also very good. This so we this ZBS and ZCS also very important things. We generally this kind of based on the resonance only that ZBS and ZCS operates. If there is a above resonant frequency, then it is automatically a inductive load. Inductive load means our inductive reactance is more, obviously more, means that and if inductive reactance is more, then the voltage leads the current, means if the voltage leads the current, then we go for ZCS operation, so that our switching losses is less. This kind of resonant thing is very important in our inverter case of thing. Most of the applications are coming now. Let us come to that phase shifting control, and why this is not moving. And this, let us come to the single phase shift technique. What is single phase shift technique? Generally, a single phase shift technique is a most popular mechanism for the dual active bridge converter. Most of the times we encounter, we use this, but there is a kind of application with the less kind of phase shift. It is okay with the better characteristics. Then we will go with this kind of, because if we go for we go for ultimately this compared to single phase shift, double phase shift, triple phase shift, multi phase shift, and all within all the things, multi phase shift is the best type of characteristics we will get, best kind of, but the circuit complexity also meanwhile increases. So we whatever based on the application we choose a technique. Now we'll go with some kind of exposure on the single phase shift technique in dual active bridge converter. Actually, it is used in power electronics to regulate the power flow between two AC circuits, and this is the phase difference between the primary circuit and secondary. Primary circuit and secondary circuit means whatever the you just now you watched about this circuit, this primary bridge and secondary bridge. This kind of thing is you will observe that phase shift. With that phase shift, that driving of the gate pulse is different. And now let us go for the some kind of important things that phase difference because of that already we discussed about this because of this phase difference will the voltage output voltages will vary that based on the circuit operation also we discussed. And this bridge circuits, this control is implemented using bridge converters. This is the control technique, right? This based on the act of switches, the control of power flow takes place. The control of power flow takes place by act of switches. Switches means ultimately the gate pulse. That whatever the power flow is also based on the gate pulse how we give. And the control signal, there is a difference in the power flow takes place because of the phase difference. The control is how it will get the timing of the gate pulse at what time, at what switching instance is very important. This applications are we use generally switch remote power supplies and renewable energy integration. We much less requirement, then we will go with this kind of application. Generally, there is a in single phase shift, the inductor current and ripple current is very much important. We have to see those, and this is a simple method. So to regulate the power flow voltage in dual active bridge converters. And its simplicity in ease of control, and it is also almost high efficient and make a variety of applications suitable for it. So we are familiar with this kind of type of thing, and this maximizes the performance. And the designers, but designers has to consider the ripple current and inductor current, whatever it flowing. Based on that, the power flow effects takes place. This kind of thing the designer has to go with. And what are the advantages of this single phase shift control in dual active bridge converter? There are flexibility, efficiency, bidirectional power. Already we discussed about this kind of thing in why you are selecting the dual active bridge. Especially we cannot discuss, but single phase shift is normal thing, not much complex, so that we can include for the better improvement of the technique, better improvement of the our characteristics of this thing. And but here there are some limitations and control of the dual active bridge. What are the limitations? What are the limitations comes under this? Harmonic distortion and voltage regulation, control complexity, not control complexity, but I have to go with this. Not a control complexity. There is a precise timing coordination of switching events, but not much. But there is a control, some kind of control complexity compared to normal conventional things. And this implementation SPS compared to somewhat. Compared to multi-phase shift and triple phase shift and dual phase shift, not much cost thing, but compared to conventional techniques, this is some kind of cost also involved in this. And now let us comes to dual phase shift operation. Dual phase shift means two phase shifts. This also operates in renewable energy and industrial applications. This is not just updated one from the single phase shift technique. It is also comes under the regulating of the power, but there is a kind of ZVS and ZCS, small ZVS and ZVS thing is involved in this. And what are the phase shift here from primary to secondary? There is a one phase shift occurs allowing the independent control of the voltage, and within the each bridge there is another phase shift. That's how the two phase shifts are appear in this for fine tuning of the and switching losses, and these are the different considerations. And see same here, but there is a dual active bridge. The advantages are somewhat little bit different from the single phase shift. There is a improved efficiency. Definitely there is a almost we are we are involving the ZS or ZBS type of thing automatically. There is a reduction of the switching losses. This reduction significantly improves the control type of nature. And there is a current regulation also. Almost we go with the voltage regulation most of the times, but this current ripple, I already discussed with the single phase shift. This ripple current is very much important. We have to decrease almost how much we can, because that affects our complexity performance. So our desired performance is not observed, so that we may feel some complex type of thing. And this current regulation also improves our regulation and smooth input current, smooth output current. And this type of enhanced current regulation helps our ripple minimization. And this type of involving the ZBS or ZCS, our optimized control thing appears. Our optimized control thing means ultimately better power transfer and reduction in the losses of the switches type of thing. And limitations, there is some kind of more sophisticated control compared to single phase shift type of thing. This manages two phase shifts simultaneously. 1 minute, sir. Now I am audible, sir? Hello?
Yes, sure.
Yes,
Yes.
audible.
Yes, sir. Yes, sir. And there is some kind of increasing in the hardware requirements. Hardware, definitely. There is some kind of ZBS or ZPS we are watching here. And there is some kind of hardware complexity compared to this single phase shift, and some precise synchronization. Synchronization is very much at synchronization means there is a instant at which instant it has to operate. This synchronization type of thing is very much important. Now let us go for triple phase shift. Triple phase shift control, somewhat advanced control compared to the single phase shift and dual phase shift. And this method, this is a additional phase shift is added based on the there is a first phase shift based on the within each leg of the dual active bridge converter. This is first phase shift is based on the primary bridge, second phase shift is secondary bridge, and third phase shift is on the each leg of the each leg means there is a independent control, and independent control takes place. This due to this independent control of the thing, our output characteristics improve, and this is the triple type of thing, we call it a triple phase shift. This type of thing has somewhat more increase in the complexity takes place, and greater degree of control of we will say that these are the things we will discuss. And there is a greater degree of the control of the power transfer compared to single phase shift and dual phase shift. And when it comes to the power transfer and ZVS optimization in TPS, we here this is the important thing. This compared to all our things are reducing our power switching losses and based on the power transfer. Then what is the difference in this? The entire difference comes under here in triple phase shift, that current stress also reduction. Generally we go for switching stress reduction, so based on the tower in output definitely increases. In addition to that, we are going with the current stress reduction. Current stress reduction takes place because of the means if the current stress also decreases, then rate of current during transition is very fine, then we will get desired output. And ZVS makes our automatically we say or whatever say we see in the dual phase shift technique, we ZVS will see, and there is a improved efficiency due to that operation of the thing. Conventional, what is the difference? Switching losses, current stress, and ZVS operation. This conventional DAP converter to triple phase shift control, there is a switching loss significantly reduced and current stress is lower. This ZVS operation is achievable in TPS control. This is highly difficult to achieve in normal conventional dual active bridge converter. And complexities, what are the complexities involved in TPS? I am not talking about any advantages or limitations in this, because if everyone there is everything there is a there has a limitations, but what are the complexities involved in our type of triple phase shift compared to the single phase shift and double phase shift technique? Is generally TPS is also very good, but reduce harmonics. Main advantage is improved efficiency and harmonics reduction takes place. This harmonic reduction is very best. This harmonics involving because of that our motor performance degrades. There is a kind of speed imbalance in the motor takes place because of this harmonics. So if our harmonics is reduced, then our we cannot get any disturbance in the output, so that we can go with the better characteristics. And triple phase shift is a better method in managing power flow and effective performance than DPS and TPS already know. And it can maximize power flow and decrease the conduction loss also. Here switching loss and conduction loss for a wider range of operating conditions. This kind of operating conditions go for wider range. For wider range also, it can able to decrease the switching losses and conduction losses. That is the important thing. This is independent phase shifting techniques we can all, because I said in each leg we can operate this type of phase shift. And what are the coming to the complexities involved in the triple phase shift? It is a type of power conversion technique. Control algorithm complexity, and there are different type of complexities involved in that control algorithm. That adaptive control, predictive control, closed loop control. Adaptive control means this controls the real-time measurements. Based on the real-time measurements, it controls the switching sequences. That is based on the adaptive, means based on the real-time load changes, real-time desired output we will get. And predictive control means this is already some kind of changes it anticipates, system anticipates, and based on that switching sequence adjusts, and closed loop control means based on the whatever the feedback loop feedback senses by the this kind of controller, that closed loop control operation takes place. And let us come to the multi-phase shift technique. Multi-phase shift technique, this name indicates this multiple switches are there in kind of this kind of thing, but not multiple kind of switch based is different from application to application. It different from our normal. It seems to be some kind of single phase shift, or but multi phase shifts are appears. This multi phase shifts occurrence takes place our better control in our characteristics. And this type of controller employs multiple switches. There is based on that, absolutely compared to triple phase shift, there is a smooth current delivery and reduced current ripple also takes place. And there is a inductive filters are placed because of there is a this updated technique, right? There is a reduction in the disturbance or noise means some kind of disturbance in the sensing or kind of thing or other kind of things. These inductive filters are very much important in filtering the disturbance. And this control logic is means switching phases edges and takes place. Output also according to that it changes. And what are the design considerations? What are in this circuit? In this circuit, the MOSFETs and inductors, capacitors, this kind of design is very important. This because we are going with multiple phase shift. Multiple phase shift means multiple kind of sequence of sensing actions takes place. This kind of sensing actions has to balanced by the inductor and capacitor, whatever we use it in our design or in our converter. For this kind of thing, we are going for most somewhat better effective choosing of the components compared to the single phase shift and dual phase shift kind of technique. And this power MOSFETs generally, we already know that as power MOSFETs we use for low power applications and high frequency applications. Wherever we go for a high frequency transformer, we can go with MOSFETs, but in our advanced stage we will go with IGBTs generally, because they are go for medium power applications and better control also. Generally IGBTs performance is good compared to the MOSFET, but low power application will go MOSFETs. In practical application, I am discussing about this. And this inductors and capacitors, the energy storage based on that design concept. If there is a high capacitance and somewhat little bit high capacitance and low ESR means equivalent series resistance. This type of thing is very important. If there is you have capacitor, further if there is a more resistance, then what is the use of that selection of that component? So with that low equivalence resistance, we can manage this type of selection. And there is applications and use cases, car ID systems and home ID systems, and this multi-phase shifting techniques we use based on this. This is my input PV voltage of whatever I am choosing for my simulation results, and this is the input PV voltage of the dual active bridge converter. Input voltage is obtained from PV for all phase shifting techniques which I took in consideration, and this is the input current whatever. This is one of the particular instant I took normally. This is the current which single phase shift of the dual active bridge converter, and these are the currents which are getting when choosing the components with our I will discuss about the whatever the parameters I took in later slides. And this is the input current. There is some more oscillation type of thing. Oscillation, not there is a not a regular kind of thing appeared because of my some kind of parameters also choosing also. This is the input current of the dual active bridge converter. There is a almost DC voltage is a almost DC. Here DC voltage is means there is a constant voltage, but when it comes to the current there is some kind of or regular changes. Based on that, current will change. Due to that, my output results here, and this is the input current operated with dual active DPS means dual phase shift technique, and in TPS this is my input current. And this, when comes to the multi-phase shift, this is my input current when I operated, and output. These are the better characteristics. These are when I compared with all these techniques, single phase shift, dual phase shift, triple phase shift, and multi-phase shift. These are the output voltages what I got with the normal duty cycle, normal PI control technique. And ultimately, I got a multiple phase shifter technique as the better one, better output voltage with my same characteristics. And this is the pulses. These are the pulses for the single phase shift and dual phase shift. And these are the load characteristics, output currents for the. These are the output for currents for different phase shifts, and these are the PWM pulses which we are based on the coding, whatever the coding we gave for the things, what are the phase shifting techniques. These are the output pulses what we got. Actually, these phase shifts by carefully timing these, based on that my outputs I got some kind of simulation results here. And these are the simulation parameters what I got. Here my input voltage is 50 volts. The input currents are like this, and output voltages I got based on that. And whatever the inductance and load I took here, I represented here. And these are the evaluation of my phase shifting techniques. My efficiency is around 92% for multi phase shift technique, and this is the triple phase shift technique around 89. My single phase shift technique. This circuit complexity is finest in multi phase shift, and some more complex kind of thing is involved in the triple phase shift because of the ZVS and other things involved in that. And let us we are somewhat more keen on AML also in power electronics, how it got and what are the things in AML, some new technologies. I will discuss those things also. And these are the some my kind of results, and these results actually there is a small kind of observation by me. These are the these kind of results while considering these parameters like my load resistance around 1000 meters, 1000 ohms, and my inductance around 1 millihenry, and my input PV voltage around 50 volts. These are the simulation results. While considering the practical results, I am not took here that simulation, that type of thing. My practical results are going on, and that practical my PV is giving around 20 volts. According to that, my design is going on in the coming days. I may go with the practical also. And this kind of thing is observed with different phase shifting techniques, my dual active bridge in EV applications. And when it comes to the actually my whatever the conclusion we got, this type of phase shifting techniques by applying and all this development and deployment of these phase shifting techniques for dual active bridge converters and in EV applications results in significant improvements in power conversion efficiency and what we already observed, and some kind of bidirectional power flow management and overall system reliability, and this kind of things I observed some in my study. And this study examined the dual active bridge converter operation principles, and concentrating on the effect of the phase shift, how much based on the power transfer and efficiency of the effectiveness of the phase shifting techniques, how optimizes my converter performance, and this kind of things actually I have gone, and you are also watching this kind of thing. And I will start with some kind of new thing, some kind of maybe interesting thing, this AML, in how power electronics you will go with, how you understand this, how go with better new technologies with different kinds of motor research motor. And this kind of artificial intelligence and machine learning are they are revolutionary fields. So are not only in power electronics, they are occurring in all fields. They are already going up. There is some kind of thing that jobs are going off, but ultimately if jobs are going off, that is not, if we leave it aside, there's that fresher coding type of thing, or fresher things, they are ultimately replacing by AI. The experienced things also only. Now AI is more getting advanced in coming 5 to 10 years. It may goes with the experienced people also. It kills that experience, some kind of experienced people. But compared to that, we are growing. We are getting into our better livelihood and better good culture of the living. We are automatically observing some kind of comfortability. Because of the comfortability, we are going with the kind of new technological advancements and new technological research we are going on. And when it comes to this kind of AML things, this concept explores how artificial intelligence and machine learning needs AML, means training. Generally, you know about ChatGPT, or kind of some kind of Google thing, Gemini, or some kind of other things. They are trained. Whatever we not trained, whatever the algorithms they run based on our training only. We are training our system. We are training our model based on our training, that acts automatically. This human is intelligent guy is human only, but training that algorithm, because of that AI or ML algorithm become so intelligent. We are only doing that. And this let us comes to the point that what are the things we have in AML things, what are the things we have in ARML things. First of all, I will give some introduction about AML and power electronics, how AML transforming power electronics, what are the key benefits for the AML power control, and how why we are going for AML in real-time optimization, predictive maintenance, and all the things I will give you. And we will go with some kind of controllers also for dual-active bridge type of thing. There are almost whatever we have traditional control things only, we are just integrating, we are just playing with the AI, some kind of if we think like a, just we are playing with a new technology like that, we can all easily integrate with this kind of things, whatever the models we have, that adaptive control, model predictive control, and these are only will come some better in better way. And there is I may not be discussed with the type constraint. I may not be discussed with real-time implementation or AML controls, or application of the AML controllers in EVs, and kind of things. But I will discuss as my kind of thing better in a better way. This concept actually explores the already I said about revolutionary things are came, and this critical development of this kind of technology makes our optimizing power systems and minimal energy consumption better than our conventional things. Conventional things, whatever these phase shifting techniques and all this, these are different. And our AML, or whatever that our AI trained is somewhat better advanced. Some I will go with, I will show the simulation type of things also, tabulated thing, whatever I choose, not before. So I will go with what are the I got with conventional technique and AI technique. What is the improvement you will watch in the coming slide. And this AML is changing the landscape of the power electronics, automatically moving with traditional methods and advanced that shift towards intelligent and data-driven systems. And now, what is determined by transforming power electronics? What transforming power electronics means? What it is going on? It's actually optimizing our whatever the data we are handling. we are enhanced control means some real-time adjustments. Here, generally, there is a work also going on we are traditionally know about MATLAB, LT-Spice, and all those things for our research work. But now in industries, real-time industries, whatever is going on, whatever the practical experience of the voltage output characteristics or the speed torque characteristics of the machine is now they are integrating like a software in a software like the performance of the uh, real time practical equipment, so that our we may not buy the equipment also in future. That kind of technologies are coming, that kind of evolution of the evolution is takes place. This kind of evolution actually makes it is good for technological development and comfortable living, but we have to cope up with that skills, and we have to go forward with that skills so that we can go with better understanding in the future technologies. And this kind of whatever we generally we buy the equipment, we do the simulations, that kind of thing, the simulations also we call it some other name, emulators we buy and all we do that. That kind of thing also in future may not exist, because of if the softwares are developed like this kind of practical implementations also, like MATLAB, if some other software will come with good practical understanding and with not in even in harmonics also better identified. If suppose if we take in the case of inverter, if we case in the take of rectifier, or whatever the things the practical how we observe, this kind of things are coming. So these are techniques. I don't know about whether they are integrated with AI or not, but they are coming. I may think it may be just definitely in future, in coming future, the AI integrated things also will exist, so we have to plan accordingly. On this kind of coming to the point, this transforming power electronics was thus AML allows us real-time adjustments in improve efficiency and responsiveness, and whatever I discussed now. And this kind of changing conditions makes our optimized popular, and generally in real-time applications we completely go for huge changes. We generally we can't, I can't say, but we are playing with the system, or we go for different kind of environments the based on that. So this kind of enhanced control is go transforming takes place, and this predictive analytics means initially with the time whatever the load changes you go, initially that prediction takes place, that due to that prediction that problems solving automatically takes place. This kind of things generally comes under AI or ML, and there is a vast amount of data actually. Actually, suppose if we go with electric vehicle only, there is a telematic unit generally. Telematic unit, what it does, even if that product is completely went into the market, even that went into market, suppose that company, I don't say the company, some company has that kind of servers also. Even every car company, even every electric vehicle company has that kind of thing. Even you that product is comes goes into the market also, even they collects data for their further development or research. That kind of data is only we are taking generally as a research purpose. Generally, suppose that wind forecasting or solar forecasting, we take some data from our organizations, well-known organizations like that, how they connected, like this type of thing only. Suppose I may connect to electric vehicle, there is a telematic unit that collects. Suppose if this, hello sir. Hello, sir. Am I audible?
Hello, yes, sir. Yes, sir, you can go ahead.
Okay, sir. Okay, sir. There is some kind of noise came. Someone said something I don't not that cannot hear properly. What? Okay, okay. I'm going. I'm going forward now. This is the type of parallel transforming takes place, and this kind of telematic unique monitors. Suppose if the auto person starts here, sir. If the auto person starts here, they from if they went to some kind of place and again starts the for particular kilometers, how much battery charging, how much battery discharging, and how much that kind of losses are coming into the region. What are the characteristics of the regenerative braking, and all these are observed by the in the telematic unit by the company servers, and they will use for other use type of thing. This kind of thing is storage of data is used for our AI and ML models. That is the interconnection what I am discussing now. And this kind of transforming power electronics, this type the how this is how that power electronics comes under AI ML transformation. And this is the there is a real-time optimization of the data. There is a data acquisition, or what I said just now, sensor collect data and various aspects automatically. Who collects data, that sensor collects data, the voltage and current, temperature and load variations in particular area. This actually this product goes into all our area. At that particular area, they will select the parameters based on that area. The suppose India there is a different characteristics, then US there is different characteristics, in European countries, in Australia there is different characteristics. Based on that, this AI/ML analysis are very useful. Predictive maintenance is very important. Sir, anything problem, sir? This predictive maintenance is very much important in kind of this thing. If any failure takes place, this AML, AI or ML predicts how the time frames and all the things. And this is the kind of just maintenance kind of thing only. And this what are the AML based controllers for phase shifting techniques? How they are dynamic, they whatever the conventional thing only. Here when comes to the AML, there are some kind of controllers. I will discuss in coming slides also that controllers also. This is how the dynamic adjustment and efficiency of the converter and how the phase shift takes place. And this kind of improvement already whatever I have observed in the simulation, but I didn't have I didn't included any simulation results of the AML here. And this kind of traditional control or fixed control and static control of parameters, wherever when kinds of AML kind of thing, we are dynamically data is adjusting based on the data, predictable data. It adjusts automatically, so that our control is very fast. And this adaptive type of changing conditions minimize energy fast changes. There's energy losses also minimizing across the switches, or conduction loss also decreases. So this kind of traditional type of control and AML type of control differs. And this kind of AML makes our maintenance cost reduction and failures also addressed before the system outage. Almost about people know about outage, what it does and all the things, damage, how it damages, and this also saves our costs and things. And this is the control algorithms techniques used for the DAP converter. What are the techniques, sir? Reinforcement learning, deep learning, adaptive control, model predictive control. These are the almost similar to the our conventional controls only. Just we are integrating, we are making our like our food we eat. So we are digesting this kind of new technologies so that we can work on it and we can get better outcomes from this kind of area. And these are the actually these are the promising solution for the whatever the challenges we face with the dual active bridge converters or conventional phase shifting techniques. And based on this type of algorithms, we adapt to this changing conditions. This control offers significant performance and improvement, efficiency and robustness and all those type of thing. And this kind of reinforcement learning means what It generally reinforcement learning is it allows the controller to optimize the control actions like trend. This is like a trial and error method. Whether the control okay acts okay, or else it will go for again trial and error case. Based on that, it will interact with the our controller and our motor. So in electric vehicles specifically I am saying. And deep neural networks. Neural networks is like our brain, there is a have a different number of neurons. And like that, this kind of thing, whatever any kind of disturbance happens in the controller converter, there you can find this kind of deep learning uses deep learning control algorithm we can use. And there is adaptive control. Adaptive means different load changes, the continuous load changes. There is the control is very simple and faster. That is the adaptive type of control takes place. And model based control, it is a future type of thing. Is easy before it predicts whatever the thing based on the study or based on the data what we have, based on the analyzing factors, based on that it analyzes and it predicts, and based on that control action takes place. This is the type of in detail whatever I said, this adaptive control, the improved enhanced efficiency, improved robustness, reduced design complexity. These are all the predictive models and all reinforcement learning. These are the some kind of signals are there, and these are the simulation results actually comparing with AI and conventional control. I kept this actually. Conventional means efficiency. What I observed this kind of by using this kind of algorithms, this efficiency is around 85. When it comes to the means my multi-phase shift is somewhat better because of the my design is different. When it comes to AI optimizers, almost I am getting single phase shift characteristics here 84% to 92% almost like that. There is a switching loss also very less. Based on that we can go for still if we can optimize AI more, we will cost my efficiency will go for 98% also based on my parameters. And there are much more things, sir.
Hemanth, you please carry on.
Yes, sir. Yes, sir. These are the general simulation things, whatever I observed, and there is a simulation also comes under demonstrates real-time adaptation to load changes. Whatever here in AI, the finest thing, the most major thing is real-time adaptation to load changes. This is the major thing you guys have to know. And this actually how it happens actually. First initial load, it senses that converter operates efficiently at initial load with AI controller optimizing phase shifting as some minimum loss. If there is a load increases, then whatever the things happen as the load increases, the AI controller adapts whatever the AI controller before only by using one of the control algorithm, it adjusts the phase shifts, and based on the control parameters, you obtain the optimal based on the and based on the phase shift, adjusting phase shifts and the control parameters, it will maintain the optimal performance. Whenever the load decrease also same in the case of the AI controller, dynamically it adapts to the reduced load and efficient operation takes place. Then whatever the efficiency and switching loss improvements with AI, this reducing losses and higher efficiency and adapt optimization. What means reducing switching losses? Means AI basically control minimizes switching transients. There is a kind switching transients means harmonics, almost harmonic. Here also, whenever come to the whatever conventional control, there are here also there are switching transients, but how minimum which minimum time we minimize that switching transients is important for our better performance of our converter or better performance of our drive or whatever we use as we choose the application. This results in the switching losses, lower switching losses, improve efficiency, and higher efficiency means less energy consumption. The error of thing already we discussed from conventional thing of conventional thing. And adaptive optimization means AM algorithms continuously learn and adapt to the converter operation by ensuring maximum efficiency based on the study. They continuously adapt to this particular type of things. And what are the simulation tools? What are the simulation tools generally we go for is in kind of AI. popular tools which include MATLAB, Simulink are traditional tools. Python with libraries like TensorFlow, PyTorch, and specialized hardware in-loop simulators. The kind of simulators we have to go with if we want to study now with AI technologies. What are the advantages of the AML type of things for DAP converters? The advantages means compared to traditional advantage, AML can optimize the converter operation. Based on that, it adapt to the various load conditions and disturbances. Based on that, it is a diverse operating scenario and reduce design complexity. And design, we generally go for design much more thing. Generally, we yes.
வந்து இப்படி ஒரே ஹோட்டல் இப்படி வந்து டேரக்ஷன் இன்னும் எங்களுதே மேப் இங்க இருந்து வந்து இங்க இறக்கி எல்லாம் போட்டிருக்காங்க. உள்ளுக்குள்ளேயே எல்லாம் இறக்கிருக்காங்க. ஆமா அதான் இந்த சைடு தான் வெளி சைடு தான்.
Hello, sir. Am I audible?
You carry on.
Yes, sir. Yes, sir. And this dynamic adoption, this dynamic type of adaptiveness is very, very much important in kind of AI we find in kind of yes, normal simulations, normal kind of conventional things we can't find this, and there is a reduced design complexity. Here in kind of one of the adaptive control or model predictive control. With that we can analyze that components, we can dynamically adapt based on that, so that the complexity of the complexity of the operation of the converter decreases, and it manages tuning also. Generally in control actions, in control type of thing, we have to tune we based on the KPK values in pay control. That if we integrate our technology with the AI type of thing, then we automatically it senses and automatically it runs. But ultimately we are somewhat well versed with our traditional technologies, and we can enjoy with our new integration of the technologies like this. And there are so many things to discuss, but time constraint, I stop here. Much things, if any things, I will. Okay, much more, not much more things. I have almost discussed whatever the things I have to discuss. Thank you very much for this session. Yes, sir.
Okay, thank you, Hemanth, for your very informative session. So, from the esteemed participants, any questions you have, so he can also answer. Any queries, please let us know. So we have to start the next session. Okay, so I hope no queries from the participants end.
Hello,
Okay,
sir.
so, okay,
Hello,
okay.
sir.
So, yes, please ask, please.
Sir, I have one question. Whether this AIML can be, is it implemented in hardware or only HAL you have implemented, sir?
This is not implemented in hardware, sir. This is just a simulation type of thing only. We are concentrating on hardware also.
Okay, what are all the parameters you have considered for that, sir? I'm not able to find.
Yes, sir.
What are your parameters to find the efficiency? How you are calculated? Means not output by input. So, what DAP parameters you have considered for to evaluate with the machine learning control, and which type of machine learning control you have used? I'm not able to see in the slides, so that's why I'm asking.
Yes, sir. Yes, sir. Actually, this this type of machine learning used is that model predictive control predictive control type of thing we use it actually. This actually we take look at the input by output type of thing only, but exact things we took from help from one of the software person from industry. Based on that, we took exact things. I can't say, but some kind of input by output relation type of only we took, sir.
So okay, sir. I'm not able to find. So means see, if we want to consider any implement for the means, what are all the data parameters you have considered? That's what I'm asking. So generally, to control with any type of machine learning, we will go for output voltage or inductor currents, or something else like error between the input and means output and the reference one. So like that, I think it was not considered. So
Actually, this is based on the forecasting things we did, sir. This is not output, input, this kind of reference. Based on the data, what we have, we did with that.
it's okay, sir. Okay, okay, right, sir. Thank you.
Hello, sir.
Yes, sir.
So firstly, Pratyush, sir, thank you so much for such wonderful lecture. Sir,
Yes,
I have basically, sir, two questions, sir.
yes,
So,
sir.
the first question is that as you told about the dual active bridge converter,
Yes,
so the control strategy, we use single phase shifting and multiple phase shifting, sir.
yes,
So,
sir.
sir, how this control strategy like MPS, SPS, DPS means why it is required, how it controls the power flow, means why it is required to make a phase shift among the two circuits which are galvanically isolated. So
Hmm.
is there any means something to do with reactive power control, active power control? And so the second question is that means why DAV control converters, why others are not, means how it is different from other DC to DC converter. Thank you, sir.
Yes, sir. Yes, sir. First, I will answer with your second question. Actually, this dual active bridge converter is took based on the research paper study. In IEEE paper, some kind of different converters, this half bridge converter, full bridge converter, and based on the different study only, we found one of the paper. This dual active bridge converter, multiple dual active bridge converter are giving better performance with efficiency around 90% crossed. So that we choose actually this kind of topology first initially as a experimental purpose. We will go for other topologies also. This is the second question. I actually what I took. And your first question, can you repeat once, sir? That
Yes, sir. So the
yes.
control strategy, sir, you implemented like MPS and SPS. So means why phase shifting is required among two circuits, means is this has to do with the reactive active power control? Means why phase shifting is required, sir, to power flow
Yes.
controls?
Actually, this phase shifting is requires because to reduce the stress on the components components and devices what we took in the circuit. For the inner components, we don't have any impact on that, so that we took, sir, actually. For inner components means like switches, like conduction type of losses and switching losses. For reduction of that, we are going with phase shifting techniques. That is the main primary thing, sir. Based on the going in the multi-phase shift or triple phase shift, based on that, we are involved with ZDS and soft switching techniques. These soft switching techniques will reduce the switching losses, and our harmonics also will decrease. So that with this type of thing, sir.
So, sir, we are not using high power rating power switches like power MOSFETs. Means we are using low power rating switches for
Mm-hmm.
this application. So
Yes,
is
sir.
it that, sir?
Actually, we have to go for high power things only. For if we want for real time execution or real time exposure, real experience about. But according to our constraints, what we have in our laboratory, if we go with high voltage, if that equipment may damage, so we are going with low power only. But we have to go with definitely high power only, sir.
Okay, sir. Okay, sir. Thank you so much, sir.
Yes, sir. Thank you, sir.
Okay, thank you, Hemanth. Okay,
Yes.
so thank you for your session. Okay, so now we are going to move our next session. Okay, so thank you. So I'm requesting just for a minute.
Thank you, participants. Thank you very much for the session.
Okay, thank you.
Thank
Sir,
you.
next.
Thank you.
Sir.